How you guys doing today? I'm Nirav Patel, and today I'm going to be talking about assignment 1. In 360, even when you do any assignments, you want to make sure that you read everything clearly, just to make sure that you understand what needs to be done. Assignment 1 shouldn't be as tricky as the other assignments, but I'm going to go step by step to show you guys how to do assignment 1, how to figure out a good amount of this program, and hopefully you'll walk out with some knowledge about what 360 is. So let me begin. First, when you want to do assignments, let's load up Vista. So, oops. So I named my group Comeback, and the type will be assignment. And remember, so this is like this is your name of your file. So my name of the file I want to put would be, let's try come back 1, and that'll be the name of the file. So before you begin, similar to how you're doing Java, you want to make sure that you declare every single file that is included. So for this is the JCL. So you can check on our notes. They say start with the JCL. In the trivia little program we had in the lab training assignment exercise. Sorry. So let's pull up the JCL, which is this one, and we'll be writing the JCL, which is job. So your ID, job, space, your name. My name is Nirav Patel. And your class, which is MSG class equals age. Next line will be step 1. Execute PMG equals assistant. Next time will be step lab DDDS dot assistant. So what I'm doing right now is I'm just copying down the JCL because that is required to start this program. If you come from a C++ background, which you guys should if you're taking this course, it's similar to include IOStream, so you could use some of the functionalities in C++. This is so you could, in a sense, use functionalities. So there you go. And you always, so the next step after doing your JCL is the header. Now, one thing you have to remember, and this is a great memory, this is what I do, is take some time, even though it might take a lot of time, but take some time to really figure out what registers you want to use and which ones you don't want to use. So let me go back to assignment 1 and read this. So part A says declare a full board num1 with the value of 249. Declare a full board num2 with the value of 117. Subtract num2 from num1. To do this, simply load these numbers into registers and use the SR instruction. Add num2 to num1. To do this, load the two numbers into registers, a different pair of registers, and use the AR instruction. Now use xdump to dump out the registers and look at the register value to see your answer. This should require xdump with no arguments. So you're like, I don't understand one thing they said. And that's okay, we're doing this to learn. Most of the time when you learn a new subject, it's very difficult to pick up at once. But throughout time, when you practice and you set time to really prep and understand this, you'll be fine. One thing I didn't do in this class was prep. And if I prep the way I should towards the beginning of the semester till now, I would have been successful in this class because I know exactly what was going on. I feel like I didn't prep enough, and when I did, it would it wouldn't be as great. And this is what I'm gonna do. I'm gonna prep you guys to do this assignment, and I'm gonna also finish up the assignment myself. So one thing you know is num1 should be declared as 249. Oops. Num2 should be declared at 117. Now you start to see, okay, now I got my variables down. How do I subtract num2 and num1? So before you start anything, this is what a prep is. You will prep to make sure what registers you'll be using and registers you will not be using. So for this course, or this course, for this assignment, let's figure out what register we'll be using. So for our register, so one thing that you have to remember is you need a register to load these numbers. So you can pick any register. I'm going to put register 3 to load which numbers. I'm going to put register 3 to load num1. And then I'm going to have register 4 to load num2. And like I said, this is why it's so important to keep reading, because if you don't keep reading, you won't understand this assignment. So it says subtract num1 from num2. Okay, so I'm going to explain subtract really quick. When you subtract the register, so R1, R2, when you subtract, you're subtracting R1 minus R2. And where does the value go? Like, that's very important. The value goes into R1. Goes into R1. And you start to see, okay, so I loaded 2 registers, and the value goes into R1. Oh, now I'm a little confused. What do I do next? Like, that was the only register I used. That's why you have to really think about this assignment well, because if you don't, this is what will happen, and you got to keep going. So always know what each functionality does in the summer programming, so you're able to really design a more fashionable way to do this assignment. So there's no worries, Why don't we do a different method? Why don't we put another register? So let's load num1 again to register 5. As simple as that. So when you do subtract, it changes the value of R1, and you see the next value, which is add num2 to num1. So the value that'll be AR register 1 minus register 2, which will be R1 plus R2, and the value will go into R1. So, God, I'm having a hard time. Hold, give me 1 minute. So the value will go into R1. So let me start doing this assignment. And I'll talk you through it. So first up, we did figure out the register. So register usage. Register reg3 would be load num1. Register 4 would be load num2. register 5 will be load num1. I think one comment which I had from, because I'm streaming this right now, one comment which I had was, okay, so you're loading registers, why don't you load another register num2? The reason for that is only the first register, only these two, are the values that get changed. So you don't want to really, you don't want to like mess around with it in a sense, because only the first registers will get changed. The second one will remain the same, so num2 will remain the same. So you don't want to mess around with it too much. So let me start main C6 using main 12, I believe. And then, so you want to zero out. First thing you want to do is zero out the registers. So a way to zero out registers, wait a minute, I think I misplaced. Yep, I misplaced. Give me 1 bit. So you want to zero out the registers. How would you zero out a register? To zero them out, you would do 3, 3. So you will be, in a sense, subtracting itself. And then after you zero out the register, after you do SR3, 3, you want to make sure that you comment. So commenting code in this class alone and in anywhere that you go is so important in life. So imagine you work with a team and they don't understand your code. They're spending more time and energy trying to understand your code, and you would, in a sense, spend maybe it'll be like an hour code. It'll go up to 8 hours because they don't understand your code and they're trying to decipher what your code is trying to say. One thing that I have worked with other people before, and working with other people, you start to realize, hey, I don't understand your code. Now I got to go out and backtrack to understand your code and comment on it. The reason I want to comment on it is because if my boss looks at it and he's like, okay, I know exactly what he's doing, why he's doing it, and how it would affect. And for you personally, you want to comment so you could have an easier time debugging. So imagine that you have a debugging problem and you can see, hey, why did I think a certain way about this problem? It's always great to really comment your code. And that's what I'm doing right now, is commenting my code so I understand, hey, I zeroed out register 3 and I know exactly why I'm doing that. And when you comment, be as detailed as possible. Very much detail oriented as possible. It takes a lot more time and effort, but it's always great to be detailed so people would understand. So I guess one person did ask me a question, and that was, hey, I know you're doing a great job and all, but why subtracting yourself would zero out the value? That's a great question, and I'm going to solve it to you right now. So when you have a register, we go 0, 1, 2, 3, 4, 5, 6, 7. That's how it is. Every register in default, 1, 2, 3, 4. So every register default has Fs. Every register default. So when you subtract F by F, what do you have? You have zeros. So that's why everyone zeroes out registers, is because by default, if you do register 3 by default is 8Fs. And if you subtract it by itself, it'll turn out to be 0. That's why people zero out the values. So after zeroing out the values, you want to second half load the variables. Now you don't have the variables yet, so you had to create it. And I usually put the variables on the bottom. It's more clean to put the variables on the bottom, so you're able to see it more. I believe it's 149. Let me double check. So num1 would equal 249. Num2 would equal 117. And don't forget to comment. So after you create the variables, you would load the variable. Give me 1 minute. Oh, so you guys are probably wondering what DC and DC means. So here, I'm going to explain to you guys what DC means. So let me first, I'm going to keep this because this is great material to look over. So DC is similar to how you guys have constant variables. So imagine you, in C++, it's called constant int or constant variable, and then you put the name, and that will equal 7. And it won't move. You can't change it, you can't do anything with it. Similar to assembler programming, there is constant variables. DC means declare constant. So when you do num1, DC forward 1 for 249, you are declaring a forward of 249. So that would be a variable. You are declaring a variable. I feel like that is, oops. So I'm going to explain this in C++ terms because anyone that takes this course should go by the first C++. So imagine you have, like I said, the constant int is probably the best way to describe this. But another way you could do it is imagine that you have a variable that you don't want to change, that you want to keep the same forever, you know? That would be what a declare constant does. It will keep the variable forever and it won't change it. You could try to change it, but it won't happen. It will probably show up as an error at the end of the day. So when you declare constants, they're usually in assembler programming, you're declaring constants to format your design in a sense where imagine you have an entire data that you streamed out, and you're like, okay, I want to create a design where I could factor in spacing along with everything else. So that's why you would mostly declare variables, but some people declare it this way. It doesn't really matter, but well, as we go on to like new levels of functions, or not new levels of functions, as we go on to new levels of programming, as we go up to higher levels of programming, you'll see this more in fact. So load, is so you're loading a variable which is num1, then you want to load that. So load 3, load num1 to register 3. And make sure to be detail as oriented as possible. Don't say load num1. Doesn't help out at all. Load okay, so you guys are probably wondering what load is. I think I got a comment on that. So why don't we use the variables to add up things together? Well, load is done by register and something called dx of b. So the variable right here is a dx of b format. So when you load a register, you will have to go with this format of load register, comma, dx of b. Now if you want to, load register is different. So load register is R1, comma R2. So you're loading you have two registers already created, and you want to load one register to another. That's what load register is. Remember the R in front of it. And if you're just loading a dx of b to a register, you just put load. And that's why I did load on this one, because this is a dx of b, and I'm just loading that file onto it. And after you load up, you're like, okay, now I'm ready. Let's go. Let's do this, Don't forget, you still have register 5, which you still have to load. So let's load register 5 really quick. Okay. Now let's do, okay, so you're like, okay, now I got everything loaded. What do I do next? So you got these two already done. Now you got to subtract num2 from num1. So how would you do that? So we subtract num2 by num1. So 3, comma 4. Subtract register reg 3, which is num1, and like I said, be as detail as oriented, and like I showed you in this example. So when you subtract, let me show you. When you subtract register 3 from 4, you are subtracting num1 minus num2. And the value will go into register 3, which is what the value would be. And let's see what you gotta do. After that, you don't have to do much. So let's do a add register. Five from 4. Nope, this is way off. Like I said, when you try to do this, make sure that you stay calm. I was trying to rush it, and that's probably the worst method to do. So in programming, a lot of times you want to take a break and you want to relax, because it could get intense. Programming is not an easy thing to do, because you're using both logical and your creative brain at the same time. So you're trying to think of ways to do it. So, right. There. Okay, I think I missed a step. So here, and I missed a lot. Branch 14 and main. I'm not sure if this will work, so I'm not really. Yep, I knew that wouldn't work. So when doing debugging, you want to make sure that you're able to really figure out what you're trying to do. And based on my information, it looks like I have a problem with my JCL. Yep, job failed, JCL error. So make sure you read everything. And let me see. Let me see something really quick. Okay, so I think one thing to realize, and I didn't really talk about this, is when things don't work out, stay as calm as possible. Because in anything that you do in life, the people that stay calm are people that really come back. That's what you want to do. There's no such thing as a great leader that isn't calm. Every great leader is calm. Even you might think Steve Jobs, he is a very calm leader as well. So if it doesn't work, if you have a JCL problem, I say the best way you could do it is my good old copy and paste. It's easier to mess around with, and you're able to get direct results quickly. Come back. What? Oh shoot. And always try to laugh about it, things that don't work out, because those are people that really come back. See, now you can see it. Alright, there are 3 errors. Now I'm gonna show you guys how to debug a couple of errors too. There are 3 errors. I know what the errors are, by the way. But you start to see lower 3 num1, num2, and num1 again. Now it's showing errors, and a lot of times you're wondering why are they showing errors. Read this, undefined symbol. Num1 is a symbol, and it is undefined, which means I put this branch to register 14 early on. So let me try to fix this really quick. And to delete something, you will put D in the left side of the map. Now let's try this. I think I know the error to that one too. I think that was probably one of my stupid errors. And if you ever have problems with this, always look at lecture notes, because those are probably one of the best finds you could ever have. And I think I know what the error was, but I just... Yep, you know, you did include. Why did I stop talking in the middle? So most of the time when I'm trying to think about this, I have to really be persistent. And that's why I stopped talking in the middle, just to really think about what to do. Oh, this is great. Alright. So you won't learn this on your first assignment, but I think I'm just going to teach this to you anyway. It's how to fix the bends. So let's do 0. So this is the last function that worked. So that was the last error. I gotta use the bathroom. Yeah, I'll be going over this a lot better. Like I said, this is my first video, guys, so I wouldn't say I'm naturally great, but I think I know critically what I could do. I tried to create this video on the fly, which fared terribly. So next video, which I do, I won't be creating it on the fly. I'll be really organizing and figuring out ways to really show that I can do it better. Okay, I'm gonna stop wasting time. I'm gonna show you guys how to do this. Okay, ready? So Ben is 004. So you can modify or verify an enemy that you don't have. I think I know. I didn't read the fire instructions. Is there any resource that you guys could use to figure it out? Yeah, there's a lot of resources you guys could use, and you know, there is a lot of resources you could use to figure out these programs. There are great resources online. Like I said, I never really went to class. I learned it a different way, and that's the whole reason for it. What is an abend? An abend is, in a way, wait, I think I know why. It shouldn't be in full words. Abend is basically errors that happen on your program. A lot of times you would have errors, and it's natural to have errors. The only thing is that you don't want to have too many errors in a sense. No, Have I done this program before? Yeah, I have. Have I struggled this much with this program? Not really. I finished in like 5 minutes. Why am I so bad in this program? It's like I said, I did struggle with this class, so I think I understand why I'm bad in this program. Yeah, so I do, like I said, I'll do another stream to really define this a lot better. But at the moment, I can't do another stream because I'm on stream right now and not looking great in my first action. For assignment 2, I'll be making sure I prepare this material a lot better. I thought I could wing this, but in reality, you can't wing anything. Why not use my 20? I don't know. Declare, yeah. It should be declared. DS. I don't think it'll be DS. It's empty storage. Empty storage. It would be declared constant. What else would it be? Why don't I give up? Because when you give up one time, you start to really figure out that when you give up, you lose like, I guess this is a great question. When you give up, you lose a sense of urgency in a way. Like people give up on stuff quickly, and that really makes you. No, I wouldn't say weak, but it wouldn't make you as great. If I ever give up, yep. Yeah. I just had to read the errors a lot better. So let me do that. There are no errors. Yeah, there is. If there is an event, there's an error. An event says I'll be back.